Okay, so in this boot camp, basically we are going to discuss about Docker. We will be discussing about what is Docker, what is the use case of Docker, where we can use Docker. Okay, those things we will be discussing about how we can build a career in Docker, how we can accomplish the Docker certification. Okay, those things we will be discussing in this webinar. Okay, so about the instructor. So myself, Gaurav Dare, and I have done my graduation, my bachelor's of engineering in computer science, and I'm a Red Hat certified system administrator. And currently I work as a cloud architect and a DevOps engineer. So let us start with the introduction of the Docker. Before starting the introduction of Docker, it doesn't matter whether you belong to if you are a developer or you work at the operational side or you are like very new to the IT. Okay. So if you are a developer or you are an operational, if you work at the operational side, so Docker is something which you can, where you can build your career on. Okay. Because Docker is basically a tool of DevOps. Okay, what is DevOps? So DevOps is basically the combination of developers and operations. Okay, so this tool is basically for DevOps. Okay, if you are a developer, so then also it is a helpful tool. If you are an operational guy who works with servers, who works with virtual machines, okay, then also Docker is a very helpful tool. So let us discuss about the changing IT landscape. So earlier we used to build our applications on the on-premises, and after that we started building our applications on the cloud. And after that we started implementing the approach of DevOps, okay, where the DevOps professional or where the DevOps engineer is basically creating the application and deploying the application. So before basically more getting in depth on Docker, let us discuss about cloud. So cloud is something which is all the companies these days is trying to migrate their on-premise infrastructure to the cloud. And all the companies are trying to adapt cloud. Okay. If we talk about any organization, either they are creating their infrastructure on the cloud or they are migrating to the cloud. Okay. So there are lots of job opportunities in cloud as well. So Docker, basically, if we are using Docker, it doesn't matter we are running in cloud or in on-premise environment. We can implement Docker in cloud also. We can implement in an on-prem environment as well. So almost 80% of companies in the market today is trying to accomplish or trying to adopt cloud. So this is basically the traditional earlier how we used to deploy the application. Okay, there are different types of application. One is monolithic, and one is one is monolithic, one is slow changing application. Okay, which we deploy on our servers. So here you can see there is a big server. Earlier, when we used to deploy an application, let us say if I want to deploy on a website, so we used to purchase a big server. On top of that, we used to install an operating system such as Windows or Linux. And on top of that, we used to deploy our application. So let's say earlier when I used, before Docker, when I used to, in the old 90s, when I want to launch a website or when I want to host an application. So this is basically the server. And on top of that, we used to deploy our application. Okay, let's say this is our application code, and this is our database, which is running inside on top of the server. So on one server, we can deploy only one application. On one server, we can deploy only one application. Let's say this is our application. This is app, and this is the database. So earlier we used to deploy only one application on a one server. One server, one application. Okay, we were not able to deploy more applications on the server. Okay, and if we talk about resource consumption, so let's say this is the resource consumption meter. So let's say in our server there is 16 gigabytes of RAM. And if I deploy the application and the database on the server, so let's assume 10 GB of RAM is consumed. And rest of the other resources, other 6 GB RAM is getting unutilized. Means that resource we are not able to utilize it. Okay, we are not able to utilize all the resources of the server. Okay, so after that, this was basically how we used to deploy an application in like before 20 years ago. Okay, in 90s, this was the architecture we followed to deploy the application. So there we used to have a server, we used to have an application, database, and the resources where we are going to deploy the application on. So after that, we came across another technology, which was virtualization. Okay, we came across another technology, virtualization. So in this case, in earlier 90s, we were not able to consume the server resources. If my application is consuming 10 gigabytes of RAM, that 6 gigabyte of RAM was not utilized. Okay. So after that, we had the concept of virtualization. So in this case also, we have a big server. But on top of that, instead of deploying the application, we used to deploy virtual machines. And on top of that virtual machine, we were used to able to deploy our application. Okay, this is our hard server. And on top of our server, we have installed a virtual machine. And on top of that, we have deployed our application, okay, which we used to do in the earlier 90s, the same way we used to do in the earlier 90s. But in this case, we were not able to consume all the resources. Okay, we were not able to consume all the resources. Plus, the limitation of this architecture was we can only deploy one application. We cannot deploy more than one application. So after that, after some time, another concept came in, which was of virtualization. And using virtualization, we can create virtual machine. And on top of that virtual machine, we can deploy our application. So one application in one VM. One application in one virtual machine. Now let's say if I want to host multiple applications, so with the help of virtualization, it is possible. Because in that case, we can deploy more virtual machines. Okay, this is virtual machine 2, virtual machine 3. And here are our application, the application and the databases. So in this case, we can deploy more applications on our server. So in this case, I'm able to deploy 3 applications on the server. But earlier, I was only able to deploy only one application. But in this case, I'm able to install 3 applications plus If we talk about the resources, let's say the server has 16 gigabytes of RAM. So we are able to utilize more resources of the server. Okay, we will be able to utilize maybe 15 gigabytes or 14 gigabytes of the resources of the server. Okay, more resources we will be able to utilize and more application we are able to run. And this concept is of virtualization. So basically what is virtualization? And virtualization, basically we create virtual machines. And in earlier in 90s, we didn't have any concept of virtualization. And in that case, we were only able to deploy one application. And the resources were not able to utilized. Means we were not able to utilize all the resources. Okay, like here, the 10 GB of RAM is consumed and the rest of the resources were underutilized. So in this case, you were only able to deploy one application and use resources were not fully utilized. But when virtualization came, then we were able to deploy multiple servers. Okay, I mean multiple applications on the server, and the resource utilization was much better as compared to other servers. Okay, anyone has any questions still here about the traditional application deployment and application deployment using virtualization? And also this application which we are running is basically, this architecture of application is also called monolithic architecture. Okay, this architecture is called monolithic architecture, which means in our application, let's say our application is Amazon.com. Amazon.com has, they have carts, okay, where we can purchase our products. Okay, like they have multiple things. They have cards, they have payment options, they have product galleries, and they have several other options which are available in their applications. So we are coupling all these applications inside one single application. This is basically called monolithic architecture, in which we have different services coupled inside a single application. Okay, this is basically called monolithic architecture. So even in the case of virtualization also, we use the monolithic architecture. Yeah, so here we are discussing about monolithic architecture. So this is the application code. Let's say our application has some product features, card, payment. So all the things were integrated, all the things were coupled inside a single application. Okay, and but in this architecture, these were the issues which the developer was facing, which are minor code changes require full recompile and retest. Okay, let's say if they have made any changes in one of the component of the application, they have to deploy the whole application again. Application becomes single point of failure, which means if one of the product inside this application is not working, so the whole application becomes down. And it was very difficult to scale up the application. In this architecture, in monolithic, it was very difficult to scale the application. Okay, if we want to make the application highly available, in that case, it was not possible in monolithic architecture. But with the help of microservices, we can distribute or we can break the application in multiple applications. Okay, as we saw in the diagram, here we have 4 applications. This is one big application, and this application has 4 services. Okay, let's say this is card service, this is some other service, this is payment service, and this is product service. So with the help of microservices, we can break this application in multiple services, which is basically called microservices. The advantage of using microservices are, let's say if one of the application, if one of the service gets down, so in monolithic, the whole application used to get down. But in microservices, if one of the application gets down, so one of the service of the application gets down, so the application is not completely down because other services are still up and running. And in case of microservices, it is easy to scale up and scale down. Okay, and if there is some changes in one of the service, so it is easy to recompile and it is easy to deploy in case of microservices. But in monolithic applications, so these were the issues which we faced to deploy the application or to develop the application. Then we have the CI/CD, which is recently introduced in the last 5 years, where we are deploying the application using a single pipeline. Okay, where we have the development stage, testing stage, and the production stage for our application. Okay, so here basically in CI/CD, basically what happens is it is basically an automation pipeline. Okay, now let's say some company is trying to create an application. So the company has developers. Okay, let's say these are 3 developers, these are 3 web developers. Let's say these are 3 Python programmers, and they are writing some applications to be deployed on the, they are writing a web application, okay, which will deploy a website. So these developers are writing code, and at the end of the day, they are pushing the code to GitHub. Okay, they are storing the code to GitHub. Okay, what is GitHub? GitHub is basically a source code repository where we can upload our code. So they are uploading the code inside on GitHub. And once they push the code, we have a CI server. CI basically stands for continuous integration server. And the tool which is used in CI is Jenkins. There is Jenkins, there is TeamCity. Okay, these are some examples of the CI server. So the CI server will automatically pull the code which is present in the GitHub. Automatically, CI server will pull the code to the CI server. And what this CI server will do, it will build the code. Okay, let's say if the code is written in Python or it is written in any programming language. So it will build the application, means it will install the required modules, it will install the required libraries, okay, and it will create an, it will build the application, and after that it will deploy the application. So it will deploy the application in development stage, testing stage, and staging state. This is the dev environment, test environment, and staging environment. And if all works good, then we can deploy it to the production environment. And if all works good in the staging, we deploy it to the production environment. where the application will get live. The code which the developer is writing will get live. And now the whole process is automated. Earlier, what used to happen, the developer once write the code, the developer has to provide the code to the operational guys. Then the operational guys used to build the code manually, and they used to deploy manually to the dev server or test server or to the staging servers. But using this CI/CD, the developers and the work of developers and operational is less as compared to earlier. So they just have to push the code to GitHub, and using this CI/CD pipeline, this is basically called CI/CD, which means continuous integration and continuous delivery. Means once the developer push the code, automatically the CI server will build the code, and automatically it will deploy to other servers. Okay, within minutes. Okay, earlier it used to take days for the operational teams to deploy the application to dev, test, and staging environment. It used to take days, but now it is just taking few minutes or few hours to deploy the application in dev, testing, and staging environment. And once it is tested, then it is deployed to the production environment. Okay, do you guys have any questions still here about CI/CD pipeline? Feel free to unmute yourself, and if you have any questions, we can have a discussion. Or you can also type it on the chat. So earlier, everything used to be managed by, there were two different teams. One was of developer and was of the IT department, okay, which was the operational team, which used to deploy the application. So if developer writes some code, then he delivers the code to the operational team. That operational team used to build the code and deploy it to the testing environment or to the production environment. So this basically, there was a communication gap between developers and communication with the operational team, which used to take days to deploy the application. Okay, but with the help of DevOps, only it takes like hardly an hour to deploy the application to the production and the testing environments. So earlier, here we can see the left side, the image which you see at the left side, it was of, this is basically called it traditional architecture, where they used to use traditional ways to deploy the application, which I showed you, monolithic approach, where the whole application, where the whole service of the application is decoupled in a single service. Then they used to use Linux operating systems, on-premise application. They used to deploy the application in their on-prem environment, where they have to manage multiple servers, networking, storage. And in on-premise, they used to use bare metal servers. Okay, bare metal server is just like our laptop or our desktop, where we deploy the application. But now we have decoupled the application with microservices. Okay, where we have distributed instances of our application. Then we have the operating system. Operating system can be either Windows or Linux. On top of that, we have cloud, where we are deploying the applications, and then we are using virtualization, through which we are basically deploying our application. Okay, earlier we used to deploy traditional apps. So traditional app, all the services which are used to be in that application was in a single instance. Then the approach of agile traditional approach came, in which basically we decouple the application in two parts. And then microservices came. And microservice, basically we distribute the application in different instances. Okay, that makes easier for the developer or to the operational team to deploy it. Now let us start with discuss with Docker and containers. So before talking about Docker, let us see the history of Docker. Okay, Docker is something which we are hearing last 4 or 5 years, but this is not a new technology. This is coming since 2004. Okay, earlier we used to have Solaris containers. Then on 2008, Linux built their own containers, which is called LXCs. Okay, Linux containers. And on 2013, Solomon's they brought another cloud container technology. And then 2016, Docker introduced their containerization platform with their support of Docker Enterprise Edition. And today we have multiple containerization technologies available. Okay, we have Docker, we have Rocket, we have Istio, which are some other container runtimes. Okay, like Docker. So if we see from the last 4 years, this is basically the growth of Docker. Right now, earlier, this was the architecture which we used to follow. This was the architecture which we used to follow. There was a server, and on top of that server, we used to deploy the virtual machines. And on top of that, we used to run the application. But since Docker came, everything has been replaced. So there are basically all the applications which we used to run in the traditional infrastructure on top of our instances, we are able to run it on a Docker instance, okay, on a Docker server. And there are over 900K applications available for Docker, okay, which includes all the common applications which we use, like WordPress or Django. Okay, all the applications which are commonly used are available in Docker. And there is 77K% hike in Docker jobs. Okay, if you go to Indeed or if you search in LinkedIn, so there is lots of opportunities for Docker. Okay, and if you see, there are 12 billion image pulls, over 398K% growth, which means there are daily images which are pushed from the Docker hub. And there are over 3,000 project contributors. So there is a very big community of Docker who is maintaining this project Docker. So as we discussed earlier, we used to have a physical server, and on top of that, we used to deploy only one application. So on top of one server, the operating system, and then the application. And the limitation of that was slow deployment times, huge cost, wasted resources, difficult to scale, difficult to migrate, vendor lock-in. And then we had virtualization, where we had the server, and on top of that we had the operating system, and then we had the virtualization software, like for example VMware or VirtualBox, and on top of that we had the virtual machine in which we are running the application. So one physical server can contain multiple applications. Okay, as we saw in that diagram, so our one server was able to run multiple applications. Earlier, we were only able to run one application, but now we can run multiple applications with the help of virtualization. So the benefit of virtualization or deploying of virtual machines is that resource utilization is much better as compared to the traditional servers. It is easy to scale. VMs are available in all platforms, whether it is cloud, public cloud or private cloud. And now let us talk about the limitations of virtual machines. So each virtual machine still requires CPU allocation, storage, RAM, an entire guest operating system to run on. The more VM you run, the more resources you need. Okay, so let's say if I want to run 10 virtual machines, so I need resources which are CPU resources, which are RAM resources to run the virtual machine. Then guest operating system means wasted resources, which means let's say if I'm running a virtual machine of 2 GB RAM and it is only consuming, let's say 1 GB of RAM, then 1 GB of RAM is wasted or it is not utilized. And application portability is not guaranteed, which means we cannot migrate the application from one host to another host. Now let us discuss what is a container. Now still there is one server. Okay, server is there. Then we have an hypervisor layer, and on top of that we have virtual machines. The same architecture still we have, but instead of running the okay, still we have the server, and top of that server we have the operating system, which is called a host operating system. And on top of that, we have the container runtime, such as Docker. And on top of that, we deploy our applications. Okay, this is our server, or we can say our hardware. Then on top of that, we have operating system, host OS. It can be Linux operating system, Windows operating system, or Mac operating system. And on top of that, we have the container runtime. And on top of that, we have our applications running. And these applications, or we can say the applications are basically running inside our containers. Now, if we talk about containers and if we compare it with virtualization or the other methods which we saw, so the first advantage of using container is no boot up, which means container doesn't boots up. Okay, let's say if you start your laptop, so it takes like 10-15 seconds to start the laptop, right? Let's say if you are using Windows in your laptop or in your desktop, so it takes like 25-30 seconds to just start, right? So Docker doesn't boots up. It means it doesn't take any time to boot up. The next advantage is no kernel. Okay, all operating systems have a kernel. Okay, now these Docker containers don't have a kernel, and if they have a kernel, so it makes them the size of the container high. Okay, and it makes the containers little. It makes the container uneasy to manage. So these containers basically use the host kernel, the kernel which the host operating system has. So let's say this is the kernel of the host operating system. So all the container uses the host operating system kernel. Okay, all the containers are using the host operating system kernel. They don't have their own kernel. Even if you use the virtual machines, so virtual machines also have their own kernel. Okay, so these containers basically use the host operating system kernels, which make the kernels lightweight. Now, if we talk about the softwares which are installed inside the kernel, so it only has the libraries and binaries. It only has the libraries and binaries which are required to run the application. Okay, let's say if we want to run a Python application, so the libraries or binaries which are required to run the application will only that container will have. Okay, in case of virtual machine, we used to deploy the whole operating system. Okay, and it has some libraries or which binaries which are not used by the application. Okay, so and those libraries and binaries used to consume some storage space, some resources, okay, which are not required by the application. Okay, so if we use containers, so container only have libraries and binaries which are required to run the application. So containers are basically meant to deploy the applications. Okay, it is not used for like it is not used for to be used for our day-to-day life. We cannot use containers for like running Google Chrome or running some let's say running some other applications inside the container. It is basically used to host applications, host websites, host desktop applications. So in that case, for that basically we use containers. So the container basically have all the libraries and binaries which are required to run the application, which makes the containers lightweight, okay, as they don't have unnecessary softwares installed in it. And the resource consumption is also less as compared to other applications, other solutions which are available, such as virtual machines. So here you can see the architecture of container and virtual machines. So infrastructure is basically the server or the hardware, on top of which we have the host operating system, and on top of that we have Docker installed, and on top of that we deploy our applications. And here you can see binaries and libraries which are required to run the application. But in case of VMs, we had the layer of guest operating system. Okay, and that guest operating system will be your Linux or Windows operating system, which will be consuming some space, some additional softwares which are not required by the application. And it is very easy to couple the application in development and production environments. Okay, we can have one VM which will be running a dev environment. We can have another VM which will be running the prod environment. We can have another VM which will be running in test environment. Okay, here you can see, let's say this is the production environment, this is the dev environment. Okay, we can easily deploy the production and the dev environment, and we can isolate uh, each of the environment from each other. Okay, the dev environment will be isolated to the production environment. So these are the key benefits of using Docker containers. Speed, no OS to boot. As we discussed, there are no boot files available in the container. So container doesn't boots up and brings the application online in even not in seconds, in milliseconds. Portability, less dependencies between prior layers, which means it is easy to migrate the application. It is easy to migrate the application from one host to another. Okay, in case of host failure, if the host failed, the application will get down. But using with the help of Docker containers, we can easily migrate the containers from one host to another host. Okay, do you guys have any questions still here about Dockers or containers? If you have any question, please feel free to unmute yourself, or you can type it on the chat. Okay, I have some questions in the private chat. So Samina is asking, yes, Samina, the recorded session will be shared. Okay, and Murali is asking, what are the challenges for running multiple applications on the same server? Okay, Murali, so let's say if we have to run multiple applications on a server, so let's say this is your server and you have to run two applications. Now, there are two applications which you want to run. Now, this application requires, let's say, uh, if you are aware with PHP language, so this application requires PHP 5 and this application requires PHP 7. So it is not possible to install and software of multiple versions. Okay, let's say if you are installing Microsoft Office, so it is not possible to install Microsoft Office 2012 also and Microsoft Office 2016 also on the same machine. So it is impossible to run multiple applications of different versions on the same machine. So this is the biggest challenge of running applications on the same server, multiple applications on the same server. Actually, it is not possible to run multiple applications on the same server because we cannot have the same application, same software of different versions running on the server. Okay, so the live training which we are going to have, this live training is dedicated for the certification exam of the Docker, which is Docker Certified Associate. Plus in this live training, we will be learning how we can deploy applications using Docker. Plus we will be seeing how we can create applications to deploy it on Docker containers in the production environment. And we will be also learning the different orchestration tools which are available with Docker, which is used to scale Docker containers across multiple hosts. So for follow-up, you can contact Matt. Matt is the meetup organizer. You can directly reach out to him by email. So on the upcoming webinars, we will be going through Kubernetes and DevOps. So do you guys have any questions still here? We can have a quick discussion if you have any questions about the webinar, or you have any question about the live classes. Okay, I've shared the PPT of this presentation of the webinar on the chat. So the class will be of 6 hours, and it will be covering uh, all the topics which are covered in the certification exams. And by taking the class, you will be ready to give the certification exam of Docker Certified Associate. It's a very popular certification, and Docker is something which is very high demand in the market. Okay, sorry, Murali, I didn't got your question. What platform? You mean the Zoom or? Yeah, you need to register on the website codingbootcamps.com. So I've shared the PPT on the chat. You can just download that PPT, and that PPT you will get that how you can enroll in the live batch.
Yeah, another question. Thank you. Another question is, which site we will be doing the lab exercises?
Okay, so the lab exercises we will be doing on top of our EC2 instances. We will be setting up an AWS account, and on there we will be launching an instance, and there we will be doing the lab. Okay, all the practice, everything we will be going to do on the cloud itself.
Am I going to get opportunity to do the labs on the live session, or it is we will be watching and following the instructions,
Yeah,
something like that?
it is a completely hands-on session. It will be a complete hands-on class. So you will be able to do all the hands-on together as we go.
That's really great. Thank you.
Okay, do you guys have any other questions? The slides which I have shared on the chart, you can go through the slides. There you will find all the links to register for the live course, and you will find the syllabus, everything is available on the site itself. The next webinar we are going to have on Kubernetes, which is about container orchestration platform. It is about how we can orchestrate our application deployment, or how we can automate our application deployment, through which we can deploy microservices. We can deploy our application in production environments. All right. Thank you everyone for joining. Have a great weekend. See you in the next webinar. Also, please make sure that you download the PPT, because there you will find the details regarding the course. All right. Thank you everyone for joining, and have a
Thank you.
great week.
Thank you. Have a good weekend.
Thanks.